The front line in Ukraine. Each day, the country's defenders fire thousands of artillery rounds at Russian forces, holding them back with frequent barrages. The source for much of that ammunition? U.S. Army artillery reserves, more than 1 million rounds and counting by early 2023. Since the middle of last year, the U.S. has sent tens of thousands of rounds per month to the effort in Ukraine, a significant use of an American stockpile meant to train and equip U.S. soldiers around the world. To backfill that stockpile and keep up with the rapid use of howitzer shells, U.S. officials said recently they want to dramatically expand artillery round production, specifically the 155mm rounds the Pentagon has been sending en masse to Ukraine.
On the conventional ammunition side, so I'm just talking about kind of the artillery production side, I believe it's the production ramp we're undergoing in terms of how fast we're trying to do it is probably the fastest since Korea. What will take us the longest to ramp up is the metal parts production. So we started there. Those are the initial ramp-up contracts that have been focused on. And there's a lot to that. It is actually pretty complicated manufacturing.
To give a sense of numbers, prior to the war in Ukraine, the U.S. could manufacture around 14,400 artillery rounds per month. But with the demand skyrocketing, officials want to increase that number to around 90,000 per month by fiscal year 2025. To get it done, they'll need to turn to facilities like the Scranton Army Ammunition Plant, where Defense News Weekly recently got a chance to see how shells are made. There, plant manager Rich Hansen gave some details about the facility and how the rounds are produced.
They're 20-foot lengths of steel. They weigh about 2,000 pounds. We cut those into billets so that they'll go into the furnace to get heated. This furnace will heat that billet or those billets to 2,000 degrees while it encircles the inside of the furnace. Then it deposits it on the other side via material handling equipment, and will go to our forge press. Here you'll see the 2,000-degree billets coming down, the material handling equipment. It'll be grabbed by the robot. The robot will present it to an optical pyrometer, basically taking its temperature to make sure that it's hot enough to press. So once the forging process is complete, the last press stroke pushes the billet down into the subway system, where it'll go down onto a conveyor for cooling.
Along a lengthy run of conveyors, while it cools, the shell is given a series of inspections to make sure it meets precise specifications to safely and accurately shoot out of the barrel of an Army howitzer and land on a target.
All right, so what's going to happen here, this is Bliss 3's hot inspection area. The operator's going to stop the part, pull it off the line with the assisted lifting device, and he's going to run through his checks. So he's going to run through a series of internal dimension checks, external dimension checks. He's going to check for concentricity, make sure that the part is meeting the technical data package high. So once it leaves here, it cools for a few hours, and then it comes out, goes through a shot blast system, comes out the other end of shot blast, and then it's re-inspected cold.
Delivered to a series of machines that polish and add copper bands to the shells, they then head to nosing, where the distinctive tips are shaped onto a rapidly reheated round. After more checks, they're delivered via robotic trolley to heat treatment, where the metal is once again made glowing hot before being dumped into a 6,000-gallon oil bath that cools it down. The process, Hansen said, gives a shell the right chemical properties to lethally shatter on impact, causing as much damage as possible to a target.
So what we're trying to do is we're trying to instill chemical properties into the steel so that it does what it's designed to do. This round is designed to kill people. So we want to make sure that when it hits the ground and explodes, that it breaks up into little tiny parts, and those parts kill people. That's what we do. We build things to kill people.
From there, they're polished and washed again, and the nose and copper bands are given final threading for fuses to be added and to fit the rifling of the big gun's barrels. Finally, they're coated with phosphate, then painted green and set aside for transport. The shells aren't actually finished in Scranton. From there, they go to Iowa, where they're loaded with explosives at another specialized facility. Creating an artillery round is a complicated process that officials said isn't easy to expand given the specialized equipment required to turn raw metal into precisely crafted artillery rounds. But the Army says that's the goal. I spoke to the commanding general of the Joint Program Executive Office for Armaments and Ammunition, Brigadier General John Rime, located at Picatinny Arsenal, about the plans to accommodate the ramped-up production.
We really got, 3 lines of effort here. Our first line of effort is how do we quickly leverage our existing facilities, right? These are our government-owned, contractor-operated facilities. I think there's 5 that are critical, in terms of what we're doing today. And I'll talk a little bit more about that. Our second line of effort is focus on industry and how do we quickly add additional capacity with our industry partners. And then thirdly, we've got a whole effort aligned towards international capacity.
The biggest challenge is increasing the capacity and speed to produce the metal shells.
Today, the limiting factor in 155 production is metal parts, and so we refer to that, as, hey, we're operating the speed of steel. So our efforts have been focused at quickly expanding our ability to produce metal parts. You may have seen that we recently awarded a contract to IMT up in Canada, and they're going to be producing metal parts on our behalf.
The service is working to build up that capability and modernize its facilities, and is adding a fully automated production line in Garland, Texas to produce shells. A new facility in Iowa is planned, and the Army is preparing to award contracts to add 2 more facilities capable of loading, assembling, and packing the shells. Some of the work was already scheduled as part of a massive modernization overhaul of the organic industrial base, but now that work is being accelerated. At the same time, the Army is modernizing the actual rounds it builds to increase range and that contains safer explosive fill. On the international side, the Army recently selected Northrop Grumman and Global Military Products to compete for orders on a contract worth over $500 million to assist other countries in increasing industrial capacity to produce 155mm ammunition. Rime also talked about what he sees as some of the biggest impediments to the process. There are some supply chain concerns, particularly in the realm of propellant charges, but overall, the Army is taking steps to mitigate any potential issues.
That's some of the challenge that, we see, that this is, kind of a niche capability. Okay. There's not a large, there is no, commercial equivalent. A lot of this stuff, this is for, military use only. And so, it's unprecedented in terms of what we've seen and kind of ramp up the production. This goes back to, Korean War era. Where we're at today, at the scale we're operating at.
With the war in Ukraine continuing with no end in sight, U.S. arms production will likely remain under increased pressure on a number of fronts. Bradley fighting vehicles and Abrams tanks are also being exported to the fight, with the Biden administration and members of Congress pledging continued military support for the months to come. How that aid plays out and the impacts on the defense industry are topics we'll be tracking at Defense News. See our coverage at defensenews.com. From Washington, D.C., I'm Jen Judson.